talk about this. So in particular, we want to look at our general form of an exponential, which is y equals a times b to the x. And think about how the a and the b change the equation, right? So first of all, we start by looking at b, which is the second part. So for g, let's see, b was times 3. All started at 50 here, and then b was times 3, f was times 2 each time, h is 3.5, and j is 0.5. So as you can see, I mean, the larger the growth factor, the more money they're going to have over time, right? It just gets a lot larger. Now, what's interesting is that when we look at this a value, so on these graphs, when you looked at those on Desmos, the only thing that changed was a. So for r, it was all times 4 to the x, but r started with 100 times 4 to the x. Q started with 40 times 4 to the x, and P started with 10. Well, where do we see those on the graph? We see them right here. So this is the initial value or the y-intercept, right? That a value is actually going to be where it intercepts the y-axis. So, I mean, I would make more with the 100 because it actually starts with a greater value. Another thing I kind of forgot to point out when I was talking about the growth factor here is that if we go 1 year later, 50 times 3 is 150, right? 50 times 2 is 100. 50 times 3 halves is 75. And 50 times 0.5 is 25, right? So we're getting these values. It's helpful to look like 1 year out. You should be able to actually identify what the growth factor is then.